here is number 12, starting with number 12 on the 1.3 to 1.5 test review. To do number 12 and 13, we have to know that, first of all, I is equal to the square root of negative 1. And I squared is equal to negative 1. And I to the third is negative I. And I to the fourth is positive 1. So if you kind of think about those exponential values and how they affect each other, you can see how that works. But knowing that I to the fourth is equal to 1, what I want to do is I want to see how many times do I have I to the fourth in my current exponential value here. So I have I to the 58th. So if I take 58 and divide by 4, that gives me 14.5. So if I take I to the 14th, or I'm sorry, I to the 4th, 14th to the 14th, that is taking 1 to the 14th. So essentially, that's 1. Now, 14 times 4 is 56, which means there are 2 left over. So I need to write that as I squared. So this is 1 I to the 4th to the 14th is 1, times I squared is negative 1, and I get, my answer is negative 1. For I to the 83, I take and I figure out how many times does I to the 4th go into I to the 83rd. Well, 4 times 20 is 80, and then there would be 30 left over. So that's I to the 4th to the 20th, and then 3 left over, so I to the 3rd. So again, the I to the 4th to the 20th is 1, and I to the 3rd is negative I. So 1 times negative I is going to give you negative I. And those are the simplified versions for number 12 and 13. For number 14, we are just simply adding. We are just combining like terms. 2 plus 3 is 5. Negative 5i plus 4i is negative I. And so I have 5 minus I for my answer. Same thing for number 15. This is just adding, so I'm going to combine like terms. Now, if this were subtraction, I would have to subtract and distribute that. But I don't have that here. So I'm just combining like terms. 2 plus 7 equals 9. 5i plus a negative 2i or minus 2i is 3i. And I'm going to get 9 plus 3i for my answer. There's nothing more to do with those. When I look at number 16, there's no plus or minus sign in between. So that means I have to multiply these out, either using the FOIL method or the box method. So 5 times 1, let me write that over. 5 times 1 is 5. 5 times I is 5i. Negative 3i times 1 is negative 3i. And negative 3i times I is negative 3i squared. So now I'm going to combine like terms. I've got 5i minus 3i. So that's 6 plus 2i. And when I have minus 3i squared, I have to remember that I squared is negative 1. So that's like negative 3 times negative 1, which is positive 3. And when I simplify this, I have 6 plus 3, which is 9, and then plus 2i. Same thing for number 17. 6 times 2 is 12. 6 times negative 3i is negative 18i. 5i times 2 is positive 10i. 5i times negative 3i is negative 15i squared. So combining my like terms, I have 12 minus 8i. Remember, this is I squared, which is negative 1. So negative 15 times negative 1 is positive 15. And then I have 12 plus the 15 to give me 27 minus the 8i. For 18 and 19, I need to get the I out of the denominator. Let me erase this stuff to give myself a nice clean slate here to start with. All right. With number 18 has 4 minus 3i in my denominator. So I need to multiply that by the conjugate, which would be 4 plus 3i. So same numbers, opposite sign. So 4 plus 3i. On the bottom, when I multiply this, this is that where if I FOIL, the O and the I will cancel. So 4, I'm just going to do F. 4 times 4 is 16. And L, so negative 3i times negative 3i is negative 9i squared. And 9i, or the I squared is negative 1. And negative 9 times negative 1 is positive 9. So I get 16 plus 9, which is 25. And for my numerator, I see that I have a 25 here, so I'm going to leave that separate from the 4 plus 3i because it's being multiplied by the 4 plus 3i. I can cancel it out. So my final answer here is just 4 plus 3i. For number 19, I'm not adding or subtracting anything. I just have one term with I in it. So in that case, I can just multiply by I for top and bottom because I will get 3i squared in the denominator, and I squared is negative 1, and 3 times negative 1 is negative 3. For my numerator, I'm going to distribute the I. I will get 4i plus 6i squared. Again, I squared is a negative 1, and 6 times negative 1 is negative 6. So I'm going to get 4i minus 6, and writing it in the proper format or order, I'm going to get negative 6 plus 4i. Now, because this top number, leading number, is a negative number and the bottom is a negative number, I'm going to factor out a negative 1 from my numerator and cancel out the negatives. But I can't just cancel right now because that's only canceling it from one term. I need to cancel it from the entire top. So if I factor out negative 1, that will give me 6 minus 4i. Now I can cancel out the negatives, and my final answer is 6 minus 4i. Yeah, okay. Moving on to number 20. This says find all solutions of the equation, express complex solutions in the form of a plus I, bi. Since I am finding all solutions and I may have complex solutions, I need to look at these to see if I could factor any of these. Okay, I cannot factor x squared plus 16, so I need to solve this like I would a regular quadratic. I could use quadratic formula and b would be 0. If I can't factor this, so I could just resort to the standard solving an equation. So subtract 16, I get x squared equals negative 16. Take the square root. I will get x equals positive and negative. The square root of negative 16, since the square root of 16 is 4 and it's a negative, it's going to be 4i. So positive and negative 4i. Number 21 is a full-blown quadratic. So I'm going to use quadratic formula. A equals 1, B equals negative 4, C equals 5. So for the quadratic formula, I get opposite of negative 4, so 4 plus or minus square root negative 4 squared minus 4 times 1 times 5 all over 2a, so 2 times 1, so 2. Underneath the radical, I'm going to get 16 minus 20, which is negative 4. So I get 4 plus or minus square root of negative 4 over 2. Since the square root of 4 is 2, the square root of negative 4 is going to be 2i. So 4 plus or minus 2i over 2. Now I've got all even numbers. I've got 4, 2i, and 2. So I'm going to factor out a 2 from the top to cancel out with the 2 on the bottom. So if I factor out a 2, I'm going to be left with 2 plus or minus I over 2, and the 2's will cancel. My final answer is 2 plus or minus I. Same thing with 22. A equals 4, B equals negative 16, C equals 19. So I'm going to use the quadratic formula. I'm going to get 16 plus or minus the square root of negative 16 squared minus 4 times 19 all over 2a, so 2 times 4. Under the radical, 16 squared minus 4 times 19 is going to give me negative 48. So I get 16 plus or minus the square root of negative 48 over 8. When I look at 48, that is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. I have two sets of pairs of 2's. So 2 times 2 is 4. So that's 16 plus or minus 4 that comes out. The negative comes out as an I, and this 3 stays in. So the square root of 3 over 8. Now if I look at these three numbers here, I've got a common factor of 4. So if I factor out a 4 from the numerator, 16 divided by 4 is 4. 4i divided by 4 is just I, and then the square root of 3 over 8. And then 4 over 8 simplifies to 1 over 2. And my final answer will be 4 plus or minus I square root of 3 over 2. And that's all I'll do for this video.